Okay, my name is Carlos Jimenez. I am a senior in computer science, and this is a presentation on the rhetorical analysis of computer science research papers, in particular in artificial intelligence and natural language processing. It was the emphasis, although a lot of what applies here will apply to many other fields in artificial intelligence as well. So about computer science, first off, it is a formal science. It's more related to mathematics and logic more than anything, although its strong empirical background and kind of the powerful computational methods, just empirically, I think keep it close to engineering departments traditionally. So the majority of universities have computer science departments in their schools of engineering. Artificial intelligence, on the other hand, is very interdisciplinary, and a lot of different researchers from all types of different fields, from cognitive science and psychology and neuroscience and so on, are involved in research in artificial intelligence. But because implementations are so heavy on computer science, it's really only what is computationally feasible that will be realized in artificial intelligence, which I think is interesting. Now, about natural language more specifically, it is primarily focused on processing human language in an automated way, and kind of computationally extracting meaning and important information from human language and text and so on. It can be more challenging than other fields in artificial intelligence even, or other fields of computer science, simply because human language is pretty messy to deal with, as you might suspect. Now, rhetorically, natural language processing is, as a subfield of artificial intelligence, it also works with, it takes a lot of the lexicon of other fields, in particular linguistics and mathematics. Now, it takes from linguistics because it's dealing with human languages, and it takes from mathematics because all of the models and um, techniques are just very, very mathematically heavy. And um, so a reader of research articles, or a researcher in the field, really has to be very, very familiar with both of these other disciplines in order to be effective at research in natural language processing. And you'll get that from reading papers. It can be very, it can get quite deep in the weeds in either of these fields as well, in linguistics and mathematics, and potentially other things depending on exactly what is being studied at that paper in the paper. And then the point of natural language processing, now, because it can be so complex and diverse, and there's so much of this background in other fields, um, research tends to focus on a particular subproblem and really just moving forward incrementally in that particular subproblem. So most papers will look at a particular problem and uh, present their own solution to um, fairly specific problems. Although these problems have been around for a while, and so oftentimes papers deal with the same problem over and over again, just making small incremental improvements. Now, the structure of a paper in artificial intelligence and natural language processing is very regular, and I think this is the case because it makes it, by regular I mean it's very similar paper to paper, and so I think it's like this to make it easier for researchers to extract as much information as soon as possible from a research paper. And it just helps researchers know exactly what they're looking for every time they tackle a new paper, and they can kind of get to the meat of the contribution that the paper makes specifically. Now, the related work section of a paper in artificial intelligence is actually very important. I think it provides a context for the contributions that that paper specifically is giving. Um, again, as we look to make, each researcher tends to look to make specific um, incremental improvements to small particular subproblems in the field. It kind of just sets the background for the state of the art in that subproblem. So they'll look at other techniques that might have been similar and emphasize how their approaches might have been different. And the implementation method, this is probably what many researchers will look to first. I think it's going to explain the technical, it's going to describe technically and mathematically the mechanisms behind the model that they are promoting in that paper. It's also going to look precisely at how the data is treated. And because natural language processing, the data is can be so difficult to deal with, it's important to process this data in a useful way. And so many papers might even be just processing the data in a special way before they feed it to a pre-existing model, and that can be a great contribution as well, and might be worthy of having a paper written just about that. Oftentimes too. So additionally, you'll always see a mathematical scaffolding kind of setup. So it describes the problem within a mathematical concept. Additionally, with the rhetoric involved here, this is where the mathematical maturity of a reader and researcher is really necessary, because it's in these it's in this section that all of this math is going to be assumed that the reader will have. They'll have access and understanding of all of the math involved here. There are a lot of pre-existing theorems that might be referred to, pre-existing models and functions and formulae that might be referred to in this section. And so it can be it can get fairly complex, and a lot of mathematical sophistication is necessary to get through this in the next sections. Additionally here, so in what I mentioned here is that you're setting up the scaffolding, you're denoting concepts of the problem in a mathematical way. So you're maybe giving names to parts of the data, or giving names to some of the functions and so on, and you're just setting the background for the mathematically you're setting the background up to describe the model in greater detail. And so eventually in the implementation problem, you'll be describing the model more specifically. And these can be arbitrarily diverse and complex. Here, for example, one of the contributions that in a paper, in a topic paper that was part of my reading, is their contribution was setting up a special objective function, and that you can see on the screen here. So this is just a special objective function where all of these symbols are describing, in this case, they're describing word vectors, or kind of points in space that are associated with a particular word. And so when they feed this into a model later on, this is their contribution. This is their paper's contribution here, is setting up this special kind of function. And so you can kind of get a feeling that math is so integral to understanding any research in this space. Now, evaluation methods are just as important, and with natural language processing, it can be very difficult, again, because the data is so messy. Evaluation can be kind of tricky. And so one type of evaluation are benchmarks that have been created, and so other researchers often will have created a benchmark that many other researchers can refer to and use. And so benchmarks are really just going to be standardized tests that you will kind of insert your model. So a researcher will insert their model to deal with standardized tests in an evaluation for a popular benchmark. And here again, just a lot of assumptions about the benchmarks that exist. Papers might assume that you know what a benchmark does or is doing. They won't take so much time to describe that benchmark specifically. you'll kind of be expected to understand what's going on with that benchmark there. And so there can be a lot of language around the idea of a benchmark or a particular benchmark that readers have to be more familiar with. Additionally, there are more generic mathematical evaluations, and these can be statistical, describing correlations, or they can be kind of custom mathematical formulae to describe to measure something that is going on with the model and the expected results of the model, um, and so on. And in this, where there is no predefined benchmark, researchers really have to justify their use of a particular evaluation and the motivation behind that use, that method of evaluation. And additionally, here just a lot of mathematical background is expected from you know, from the reader here. Finally, there will be the results. These can be straightforward as long as you understand the evaluation methodology that was described in the previous section. It's just going to be comparing the results of the authors to competitor models and prior work and so on. And finally, the conclusion section of the work. Here it's fairly simple, mostly in plain English. They'll kind of describe the contributions of their paper to the subproblem and the problem space. And then they also will often provide the source code of their implementation to other researchers that can reproduce the results as well. And so, in fact, in my case, I have the source code for my original paper if you would like to compile that in LaTeX. Just kind of a fun way of contributing source code in a traditional way.